Oh my God, what the heck is this? Oh, wait, it's a double pendulum. Just two stupid little sticks. And they made the world's greatest physicists collectively fail to predict what happens next. Think about a normal pendulum, like the one in your grandpa's old clock, back and forth. Hypnotic. So predictable you could close your eyes and know exactly where it'll be a second from now. But then you attach a second pendulum to the end of the first one. And just like that, everything changes. All order disappears. It starts going crazy. It starts lying to you. Where will it be in the next second? Nobody knows. And here's the kicker. It's not random. It's chaos. And what's hiding inside that chaos? That's the part that'll really get you. Because right in the middle of all that craziness, scientists found a few hidden islands. Everything around them is pure chaos, but the islands, completely still. So where do they come from? Don't worry. Let's break it down. Let's run a little experiment. First, let's label the angle of each pendulum. Paint the first one yellow, the second one blue, so we can tell them apart. Now let's run it again and again, increasing the starting angle of the second pendulum by just 1 degree each time. Even though they start from almost the same spot, how fast do you think they'll drift apart? Okay, now watch this. We reset them to almost the exact same starting position. And I mean almost. We change the starting angle by just 0.01 degrees. You can't even see the difference.
时放手。
Then we let them go. Within seconds, they go completely separate ways. Totally different paths. Like they were never a pair to begin with. Now shrink that difference even more. Down to 0.0000001 degrees. You know how tiny that is? That's like standing on Earth, looking up at the moon, and measuring the width of a tennis ball sitting on the lunar surface. And guess what? Chaos still shows up, right on time. This is what makes physicists lose their minds. It's called sensitive dependence on initial conditions. But you probably know it by its cooler name, the butterfly effect. A butterfly flaps its wings in Brazil. A tiny current of air shifts. That shift gets amplified layer by layer and eventually causes a tornado in Texas. Sounds like some mystical woo-woo, right? Except it's real. It's been rigorously proven in physics. And here's the really wild part. The double pendulum isn't random. Every single move follows Newton's laws. Gravity pulls. It responds. No randomness at all. And yet, this completely predictable system creates results that nobody can predict. That's what makes chaos theory so mind-bending. But chaos isn't the whole story. If you release a double pendulum from a really small angle, it behaves like a good kid, steady back and forth, predictable as a metronome, never goes off the rails. So scientists released thousands of double pendulums, all with slightly different starting angles, and slowly a fuzzy boundary appeared. On one side, calm and orderly. On the other, absolute madness. But where exactly is that line? To find out, they got creative. Instead of drawing the actual pendulums, they turned every possible starting position into a single pixel on a screen. The color of each pixel represents how that pendulum is moving. So now, 4 million different pendulums, each with different starting point, all squeeze into one 2000 by 2000 pixel image, all moving at the same time. And the whole image starts to flow, like a living painting. And then everyone went quiet, because right there inside all that swirling chaos were several motionless areas, perfectly still, smooth edges, soft colors, like quiet islands in a violent sea. Those are the legendary stable islands, the last strongholds of order, surrounded by chaos. So what determines whether a double pendulum stays calm or goes crazy? Scientists dug into the data and found one key moment, the flip, that moment when one of the rods swings all the way over 180 degrees. Once it flips, the pendulum almost always falls into chaos. No flip, it usually stays orderly. They color-coded each pendulum by when it first flipped. red for early flips, green for late flips, white for never flips. And suddenly, the whole picture transformed, from total chaos into something precise, structured, beautiful. The stable islands match the white zones perfectly. The flip is the gateway to chaos. But of course, it's never that simple. Some pendulums flipped and somehow stayed calm. Others never flipped and went completely nuts anyway. The real boundary between order and chaos, it's more broken than we thought, more complex. Kind of like a coastline. Zoom in, and there's always another layer of jagged detail waiting for you. Chaos theory has been around for decades, and the double pendulum? Still not fully solved, but it's already taught us one crucial thing. Chaos isn't a lack of rules. It's just that the rules are more complicated than we can currently understand. 2 sticks, 1 pivot point, and hidden inside, an honest reflection of how the entire universe works.